we're going to take two copper-containing ores, azurite and malachite. We'll calculate the mass percent of copper in each of these. Which one's azurite and which one's malachite? Well, azurite is the blue one, and I think of azul or azure, and then malachite is the green one. I've heard of malachite green before, for instance. We use copper in a lot of things. We use it in plumbing. We also use it when we make copper-based wire. When they dig up tons and tons of copper-containing ore, an incredibly small percentage of it is actually copper. And so they have to process it. One way they do it is through leaching methods. They will take sulfuric acid and mix it in with the ore, and then it'll act on the copper compound, and then what they'll do is they'll extract out the fluid and then do further processing on it. Let's start with azurite first. A sample size is important. We're dealing with two different compounds. And mass percent seems to imply out of 100, and that is correct. But you don't have to pick 100 grams of this. Now, on these kind of problems, if you're given the chemical formula, which we are in the case of both azurite and malachite, I would suggest that instead of 100 grams, you go with molar mass. Go with moles. See, so if you're given the chemical formula, then use a mole for your sample size. And if you're wondering why it's written that way with the carbonate in parentheses and a 2 outside of it, along with a hydroxide, we don't talk about things like this as far as naming, but that's done to make sure you see there are two different polyatomic ions in there. All right, so we want mass percent. What's the definition of mass percent? Well, it's part over whole times 100. Since we're looking for copper, we need to take the mass of copper in our sample and divide it by the total mass of the sample, and then multiply that by 100. So what did I say on sample size? Pick 1 mole. So if we have 1 mole of azurite, how much copper is in 1 mole? Look at the chemical formula. There are 3 moles of copper. Okay, so 1 mole, 3 moles of copper. Let's get the mass of copper. That's just the molar mass off the periodic table. I'm going to maintain the same number of decimal places on this, since what I'm really doing is taking 63.546 and adding it up 3 times. Okay, so that's the mass of copper in my sample. So I'm going to take that, and then I'm going to divide it by the mass of the sample. Now, you're not going to divide it by 1 mole. That won't get you percent. You have to divide it by something in the same units. Well, if we choose 1 mole of azurite, how many grams do we have? Well, just the numerical value of the molar mass. So we get a little over 55% copper in that. Okay, let's do the same thing for malachite. So we have the chemical formula. So we'll take the molar mass because we're going to use 1 mole as our sample size. So this definition hasn't changed. It's just our sample's changed. All right, so in 1 mole of malachite, how many moles of copper do we have? Well, let's see U2. We have 2 moles of copper. So let's do what we did before. Calculate the mass of copper in that sample. And we're going to use that value and we're going to divide it by the mass of the entire sample, which, recall, we picked 1 mole, so we divide it by the numerical value for the molar mass, and then multiply it by 100. We get a little over 57%. And let's look at our answers and see if we can do a common sense check. You know, it's hard to really get information right away and be able to tell which one should have the higher percentage of copper by mass. See, if you compare the chemical formula, azurite has 3 coppers while malachite has 2 coppers. So my first impulse might have been, oh, azurite should have the higher mass percent. However, what complicates it is you have 2 carbonates in azurite and only 1 carbonate in malachite. So the molar masses are really different. And then that's why we end up with malachite having a higher mass percent.